Now see, this is the homework question which I gave it to you. In this, you need to calculate potential across X and Y, right? As you can see that you have don't direct connection between X and Y. So you can mark this point as C and this point will be D, right? So can we write down like you are standing at X position and you need to move towards Y position. So you are moving from X to C, C to D and D to Y, right or not? So it would be VXC plus VCD plus VDY, right? So I if you are moving from X to C, then current also moves in the same direction as I told you. If you are moving from D to Y, so current should also move in the same direction D to Y, correct? Now we'll mark the sign convention and then we have to take it according to the sign, second sign. You are moving from A to X to C. Second sign is minus 3I1. You are moving from C to D. Second sign is plus 4. Neglect this resistance because in this no current is flowing. Now you are moving from D to Y. Now the second sign is again minus 3I2. Right? Correct? So in this case, we need to calculate I1 separately and we need to calculate I2 separately. So if I'll apply the mesh analysis for the first mesh, in the 6 ohm current is not flowing now. For this it's an open circuit. It's not a closed circuit. That's why current in 6 ohm is 0. But we consider the battery in the open circuit, right? So it would be how much? Minus 2I1 minus 3I1 minus 2 is equal to 0. Minus 5I1 is equal to 2. Now from here you are getting the value of I1 as minus 2 by 5, right? So you need to put minus 2 by 5 only. Don't consider automatically positive. I1 is minus 2 by 5, so put minus 2 by 5 only. Okay? Yeah. So minus 3I2. Now we need to calculate I2. Let's make the equation for I2 also. This one is 4 volt. Yeah, so it would be positive, negative and positive, negative. So minus 5I2 plus 4 minus 3I2 is equal to 0, right? So it would be minus 8I2 is equal to minus 4, minus minus cancel and I2 will be 1 by 2. So here I2 is 1 by 2, you need to put 1 by 2 only, right? So ultimately it will become negative, negative will become positive. 6 by 5 plus 4 minus 3 by 2. Final answer is 3.7 volt. You will get it in negative minus 3.7 volt. If they say you have to say Vxy, that is minus 3.7 volt, but if they say Vyx, then in that case it would be 3.7 volt. Okay, understood? Okay, so in the last lecture what we have done, we have covered source transformation, star delta, mesh, node voltage also, and in the last lecture we have covered the Thevenin theorem, right? So now in today's lecture, first I'll teach you the maximum power transfer theorem, then I'll move towards superposition theorem. Okay, because if you know the Thevenin theorem, then maximum power is easy and it is dependent on each other basically. So what is maximum power transfer theorem? Okay, maximum power transfer theorem. In this particular theorem, they said that power should be maximum transfer to the load. Like suppose this is a load that you are using at your house. Suppose you are using one bulb, okay? And what you want, that government is giving supply. So the government which is giving supply, that power should be transferred maximum to the load. Yes or no? Yes, now it may be 80%, it may be 90%, it may be 50%, but it should be maximum. So there is one condition for maximum power. What is that condition? Only in this condition maximum power will transfer, and that condition is RL is equal to RTH, where RL is the load resistance and RTH is the Thevenin resistance, right? If these two resistances are in equal, then in that case our maximum power will transfer. So for transferring the maximum power, what we need to do? These must be equal. Got this point? Now we need to calculate power. As you know, according to power formula, P is equal to I square R, right? And you know, in the Thevenin, I formula is how much? I is equal to VTH divided by RTH plus RL. Yes or no? So I am substituting the value of I over here, that is VTH divided by RTH plus RL ka whole square multiplied by RL. This is power. So now we want that power should be transfer maximum, right? Power should be transfer maximum. For that we'll have one condition, RL is equal to RTH. So instead of putting RTH, I'm putting RL over here. So it would be VTH ka square RL plus RL means 2RL ka whole square will become 4RL square multiplied by RL. 1RL with 1RL is cancelled out. Now the final value for maximum power, you got it as V square TH divided by 4RL. Correct? So these two conditions you need to remember only in case of maximum power. That one is RL is equal to RTH. Okay. Write down this formula. I told you not to make one formula page, and another one is maximum power is equal to V square TH by 4R. So here we need to calculate first of all VTH, right? Because the maximum power formula is P max is equal to square TH divided by 4RL. Here RL was connected, that is given in the question, that was 8 ohm, and I removed RL, right, for the calculation of VTH, and that is equal to AB only. So as I told you, whenever there is a battery and the resistance in between, mark one point between them, A, C, D. Okay. Now you do it further, then I'll tell you. Try to do it in your book. You are standing at A to C and E to B. Yes or no? Now do it. You are moving from A to C in open circuit. This is 0. Now positive, negative, right? Now you are moving from D to E. Current should also move from D only, right? I told you in whichever direction you are moving, current will. So we have to take second sign every time, as I told. So you are moving from C to D. It would be -1. Okay? Then it would be -20 into I2. That would be equal to V. Now for getting I2, we need to calculate I1 and I2 by using mesh analysis. Now tell me the two equation for the mesh. Now see, these are the two mesh equation. This one is first, and then we'll have current source. After solving, we'll get the value for I1 and I2. Yes or no? So after solving, we'll get I2. We can substitute it here. Then after substituting, we'll get the value for VTH, right? And you know, power maximum is V square TH divided by 4RL. TH we can substitute it here. RL, that was already given in the question. That was something 8 ohm, right? This is how maximum power transfer theorem question solve. Basically, you have to apply Thevenin theorem only. If you know the Thevenin, then only you will be able to do the maximum power transfer theorem. Okay? Clear? See, this type of question comes in Manipal. In this, they didn't give you the value for R, and they ask you to calculate the value for R, and they said RL is this one, and they give that this is the maximum power condition. When you know RL is equal to RTH for the maximum power, RL is 8 ohm, so we can consider RTH is also 8 ohm, right? So now we can calculate RTH. As you know, for calculation of RTH, voltage source must be short circuit and current source must be open circuit, right? So voltage source like this and RL must be removed, correct? This is 2, 4 and R. This is A, this is B, correct? Now as you can see that 2 and 3 is in series, so it would be 5 parallel R, and combined it, that would be in series with 4 ohm. That is your RTH. Yes or no? If we'll further solve it, this is 5, this is R, and this 4, right? So 5 and R is in parallel with series with 4. So we can place RTH here like this. So 5 parallel R means 5 into R divided by 5 plus R plus 4 is equal to RTH. RTH is equal to 8 ohm. Now can you get the value for R? There is only one variable. This question we need to calculate RL, right? So RL must be equal to RTH and RTH must be equal to RAB. For that, current source must be open circuit, and this is delta. Delta we can convert it star, or one more, this is star, right? Star can be converted into delta, right? So I told you to mark the point, solve it, then this value become 6 ohm. Okay, now 6 as it is, this 6 and this 6 voltage source got, and this 6 and this all are in, like this one is parallel with, and this one is parallel with this, parallel with, and our rest of the circuit is same, right? Now don't consider 6 and 8 is in series, they are not in series. Okay, now after solving 6 parallel, 6 means 3, then 3 and then 3, right? 6 and again like this, so it would 3 and 3 are in series, that would be in parallel with 3 plus 3, 6, 6 is in parallel with 3, right? Will become a single circuit. Now tell me, like this is 8 ohm and this is also, like after combining, like this one is series now, right? So after combining into series, we'll get 8 ohm and 8 in parallel. So finally we'll get the value for RTH as 4. Got it? This is what they have asked in a question. How can we solve this question? This question they have given you maximum power. So maximum power formula, first write down all the formulas. We get TH by 4 RL, and we'll have one condition that RTH is equal to RL, right? So we can get RTH, right? Because calculation of RTH would be, don't need it, right? And RL value also we don't need it. So can we open circuit RL? It's like 10, 20, 30 and 10. So 10 and 20 are in parallel, correct? Will become a single resistance, 10 parallel 20, then 30 and 10. Then 10 parallel 20 means 10 into 20 divided by 10 plus 20. That would be how much? 100 by 30, 20 by 3. 20 by 3 in series with 30, right? 20 by 3 is in series with 30. That would be parallel with 10 ohm, correct? That would be parallel with 10 ohm. So this is how after solving we'll get RTH. Power maximum they have already gave 40. For RL we don't know, but RL is equal to RTH. So whatever the value you will get it over here, you can substitute it over here. Only one variable is left, that is VTH. And from here we can get VTH. Yes or no? First of all, tell me. Next, we'll move towards the superposition theorem. You can practice the question of maximum power transfer theorem by your own by PYQs, and then you can ask me the doubts, right? So next is superposition theorem. In the superposition theorem, we have to see that how many sources are there. So accordingly, we'll move it. Like suppose this is the circuit. Now can you tell me how many sources are there in this case? How many sources are there? In this case, two voltage source and one is the current source. So total three sources. So this question will be solved in three different steps. Okay, first thing, like suppose they ask you to calculate the current in 4 ohm. The step number 1, we have to take first source and remove other source, or we can say kill other source. Okay, killing means voltage source must be short circuit as we have done in the Thevenin, and current source must be open circuit. So take the voltage source. In the first step, take first source. First source is this one. Second source, kill it. Current source means open circuit. Again third source, kill it. Voltage source means short circuit. Here you have marked I, and in this branch you need to mark I dash. By using mesh or nodal, that's your wish, you can calculate the value for I dash. Okay. Now the second step, in the second step we have to take the second source only and kill other source. So first sorry, first source will be killed, second source we need to take, third source also killed, right? Now in the third step we have to take the third source. First source killed, second source killed, third source be there. Now here we need to mark I double dash, and here we'll need to mark I triple dash. Final answer will be I is equal to I dash plus I double dash plus I triple dash, because all three are moving in this direction. And you can get the current by using mesh or nodal, that depends on you. See, in this question we'll have two source. First step, first source will be there, other would be eliminated, and in the second source will be there and will be the right. Now after this we need to calculate the current in 4 ohm, so it would be I dash, it would be I double, correct? Now solve this. How many equations, how many meshes will have? 3 mesh here, I1, I2, I3, and in this have only 2 mesh, I1 and I2. Now tell me the equation for first case and the second case as well. So these are the mesh equation. I1 and 1 ampere is same, so I1 is equal to 1 ampere. Minus 8 I3 minus I2 is equal to 0. Next one is minus 4 I1 minus 6 I2 minus I3 minus 2 I2 minus 1 is equal to 0. Similarly, tell me the equation for the second circuit. And first of all, tell me, after solving you will get I1, I2, I3, but you don't want I1, I2, I3. You want I dash. I dash is equal to how? I2 only, because I dash is in the corner branch, and in the corner branch there is a flow of single current, and I dash is in the room of I2, so I dash and I2 direction is same also, so we can write down I dash is equal to I2. Okay, Similarly, for this one case, I double dash is equal to, tell me, I double dash is equal to I1, right? If we'll add I dash and I double dash because both are in the same direction, final answer current. Okay. Now, obviously, in Manipal, simple question will not come. I'll tell you how this question is modified. Okay. Now, see, in this question, they ask you to use superposition and they ask you to calculate Vs and current in 4 ohm is already given, right? So, let's go it according to the picture. Like in the first step, we have to take the first source and other source would eliminate, right? Eliminated means if there is a voltage source, that must be short circuit. This is 1, 4, 6, 8, correct? So in this we'll mark as usual I dash, correct? Can we calculate the I dash value from here? All the values are given, yes or no? Okay, so I dash we can get it by using model analysis or you can mesh analysis, right? So depend. So I dash, now we'll move towards the second step. Second step is you have to take the second source and eliminate the first source. So 2 ampere is open circuit, that would be eliminated 4 ohm, 6 ohm, 8 ohm and Vs is there, right? So in this we need to calculate I double dash, but for that we need Vs, right? So in this case, let us consider here current I. This one is I double dash. Let us consider here I1, right? They tell you one thing that I dash plus I double dash is equal to 0.515. Yes or no? Because they said na if current in 4 ohm is 0.515, so that means 4 ohm I dash plus I double dash is 0.515, and from here we can get the value for I dash, right? Then will you be able to get the value for I double dash? Yes, if you know I double dash by using current division rule, directly get voltage, or you can use again mesh analysis because now you'll have only single variable, that is Vs. Now in this case Vs is no, sorry, two variable. One is I double dash, right? And one is maybe I1 or I2, or maybe you can do it by nodal, that would be C4. Let me write down the I double dash is equal plus I is equal to I1. Yes, now I double dash already calculated. I is equal to by R. Let us consider the VA node. This is 6 K by 6, or you can say VS by or I1 is equal to this one 0 minus VS uh, plus VS 0 plus VS K divided by the 8, right? And similarly a double dash you can write it as 0 minus VA divided by plus 4 6. So basically in this you will have only single variable, that is Vs, you can solve it. Okay, how? I double dash is how much? It is moving from 0 to VA, yes or no? Sorry, it is moving away, so it would go minus VA divided by the resistance, that is 2 plus 4, right? 6. If you have I double dash, can you get the value for VA? Yes, ma'am? No, if you have I double dash, you will get it from this equation, correct? So you can get VA, you can substitute it here, then you will get this. This is also your work question. So these question is work. This is the Thevenin based and this is the superposition based. Okay.